Imagine you are offered a loan, and the lender tells you the interest rate is 5% per year. That sounds straightforward, right? That 5% is likely what we call the annual percentage rate, or APR. Think of APR as the advertised interest rate. It's the headline number, the one that is often used for comparison. However, there's another rate you need to be aware of, especially when you want to understand the true cost of borrowing or the actual return on your investment over a year. This is the effective annual rate, or EAR. The difference between APR and EAR boils down to something called compounding. Compounding is essentially interest earning interest. Let's say you put money in a savings account. If the interest is compounded more frequently than annually, like monthly or even daily, you're not just earning interest on your initial deposit, but you're also earning interest on the interest that has already been added to your account. This effect, while seemingly small at first, can add up significantly over time. Think of it like this. Imagine you are watering a plant. APR is like telling you how much water you intend to give the plant over the entire year, say 5 liters. But EAR is like considering how often you water the plant. If you water it all 5 liters at once at the beginning of the year, it's different from watering it in small doses throughout the year. Watering more frequently, even if the total amount is the same, allows the plant to absorb moisture more effectively and grow better. Similarly, with interest, compounding more frequently means you are essentially watering your money with interest more often, leading to more growth, or in the case of a loan, a higher actual cost. To convert APR to EAR, we need to account for this compounding effect. The formula to do this is relatively simple once you understand the components. You start with 1, then you add the APR divided by the number of compounding periods per year. Let's say the APR is 5%, and it compounds monthly. So you would divide 5% by 12, because there are 12 months in a year. Then, you raise this entire sum to the power of the number of compounding periods per year, which is again 12 in our monthly example. Finally, you subtract 1 from the result. This final number, when expressed as a percentage, is your EAR. Let's work through a quick example. Imagine an APR of 10% compounded quarterly. Quarterly means 4 times a year. First, divide the APR by 4. So 10% divided by 4 is 2. 5% 22. Pal. Add this to 1, so you get 1. 25. Next, raise this to the power of 4, which is approximately 1. 10, 38. Finally, subtract 1, resulting in 0. 10, 38. Converting this decimal back to a percentage by multiplying by 100 gives us 10. 38%. So, a 10% APR compounded quarterly actually translates to an EAR of approximately 38%. Notice how the EAR is slightly higher than the APR. This difference, although sometimes small, can become more significant with higher APRs and more frequent compounding periods. For instance, if interest were compounded daily instead of quarterly, the EAR would be even slightly higher. Why is understanding EAR important? Because it gives you a clearer picture of the true annual cost of borrowing or the actual annual return on an investment. When comparing different loan offers or investment options, it is crucial to look at the EAR, not just the APR, especially if they have different compounding frequencies. An offer with a slightly lower APR, but more frequent compounding might actually be more expensive in the long run than one with a slightly higher APR, but less frequent compounding. So, while APR is a useful starting point and often the advertised rate, EAR provides a more accurate representation of the real annual interest rate you will pay or earn. By understanding how to convert APR to EAR, you can make more informed financial decisions and truly compare apples to apples when it comes to loans and investments. It's about looking beyond the headline and understanding the fine print of how interest works over time.